Alrighty then, we're looking at lesson 30 today, talking about common denominators. Of course, as we look at common denominators today, we want to really get an understanding of what this is all talking about. You see, I got two fractions here, and I want to know which one is bigger. But of course, I can't know which one is bigger because they got different denominators. So to get them to have the same denominator, I need to form equivalent fractions so that they have the same denominator. Now, the first thing I got to understand is look at the relationship between 5 and 6. So look at the relationship between 5 and 6. I want to know what the least common multiple between them is so that I can really create the easiest fraction that I can make. All right? It's not coming to me. Not quickly. So maybe I just gotta multiply by the opposite. Sometimes that is the least common multiple. And so here I'm gonna multiply. I don't know why I underlined that one. That's foolish. That's confusing. Get rid of that. But here we got a real simple setup, and now I can solve, right? 6 times 4 is 24 over 30. And now I have 5 times 5 is 25 over 30. And so in the end, I get this very nice response of 5, 6. It's just a little bit bigger than 4/5. But we found a common denominator, and in the end, we actually did use the least common multiple to solve this problem. Let's try another one together. Actually, no. Why don't you try this one alone? You see, when we add fractions, we need a common denominator. So to find a common denominator by using the least common multiple, and from there you can solve. Alright, I'll let you do the addition alone, but we can kind of check our ideas by working with some subtraction together. Here we want to subtract some mixed numbers. Now mixed numbers, of course, are all mixed up. So we got to figure things out. Now normally when you write mixed numbers, you want to line things up. So we got 2/3 minus 5 1/6. Now of course I can't subtract those fractions because they don't have the same denominator. So the first thing I want to do is I want to find something common between 6 and 3. Now I could start throwing out some multiples, but the first thing I'm going to notice is that doesn't 3 go into 6 real easy by multiplying by 2? Of course it does. I see that. So the first thing I'm going to do is I'm going to take this and I'm going to convert this fraction so it's a denominator of 6, just like that. And now that I got this fraction, now I can really solve. I'm going to take this 4/6 and I'm going to subtract this 1/6. And suddenly I'm going to be left with a 3/6. Now I'm going to take this 8 and I'm going to subtract this 5, and I get an answer of 3 3/6. But suddenly I realize that this 3/6 is a reducible fraction, so I'm going to reduce this and get a final answer of 3 1/2. Did you do something similar like that when you were adding them together? Did you remember to reduce or convert to a mixed number if you needed to? Well, there you have it. We got this process. Let's move on. All right. Now, sometimes finding that least common multiple, you say, can be difficult because we get big numbers like 32 and 24. Can you find the least common multiple? 3, 2, 1? No, you don't got it yet. I doubt it. If you do, hey, congratulations. You're real good. So let's use some prime factorization, right? Prime factorization to help you find the least common multiple is all about using that swimming pool idea, right? We pull in our factors. Oh, I got to pull them in a little bit more, it looks like. There we go. And then we pull in the factors from our other one. So basically, I took the 32 and I broke it down. And when I broke it down, I got a response of 2 times 2 times 2 times 2 times 2 times. You got all those 2's. And then I broke down the 24 and I got 2 times 2 times 2 times 3. So if I want to create a pool, a resource of everything that I need, right? If I want to create 32, I got to have 5 2's. So I'm going to throw these 2's into my pool. Now, to get my 24, I already have 3 2's in the pool, but I still need the 3, excuse me. But now I throw all that together. And now suddenly I get a response, right? 2 times 2 times 2 times 2 times 2, and I know this equals 32. Multiply that by 3 then. So 32 times 3 gives me an answer of 96. And suddenly I know what my least common multiple is. It's 96. All right. So I want it to equal 96. Now the question might be, well, what do I multiply by 32 to get 96? Well, of course, that's 3 because we just did that down below. So if I multiply by 3 down here, then I got to multiply by 3 up here and get an answer of 15. But what about the 24? Well, this is where we go back to our pool to understand this, right? We know we need this to get the 24, so now we need this to figure out how to get to 96. And that's where we're going to plug in a 2 times 2 times 2 times 2. Oops, I need one more 2 in there. Sorry about that. Just a 2 times 2, which is 4, which is going to get us to 96. So then we're going to do the same on the top. Get a 28. And now I can add them together, right? Now I can do this wonderful problem. And so now I got 15, 96, and 28. So 28 plus 15 gives me an answer of calculating. There we go. And then we throw that over our 96. And it's already in those terms. Ready to go. Rock and roll. There's a new process. Put it to good use. One last sample problem to get you on your way. So use the least common multiple to add these together. Alright, go get them. I think that's it. That's it, definitely it. That's lesson 30. Common denominator.